So I'm looking at Olympic houses as as the built example of how they can be built in future in terms of the legacy plan of the village. There have been some Olympic villages in past where they have been left abandoned post the Olympics have been done. So I'm looking at how the legacy plan can be approached in other way, wherein the athletes are the users which are for temporary period, and the planning is mostly done for the people who are going to use it after the Olympics. So just a brief of the methodology adapted for the research work. As mentioned, there are two kind of users, mainly focusing on athletes and the post user, and then focusing on the urban layout for the Olympic village, going at the building level and looking at how the legacy planning can be done through the process. The site for the Olympic village has been chosen as Ahmedabad, which is potential site for the 2036 Olympics. The weather climate of the Ahmedabad mainly is hot and dry climate with peak summer temperatures during summer period, and the wind comes from southwest direction during monsoon and summer period. The climate can be classified into three periods: hot, mild, and moderate. So for the further approach, typical days were identified for a moderate day, a hot day, and a mild day, and a typical day during the Olympics, specifically during the Olympic period. And some passive strategies were identified through the climatic analysis of what can be done at the microclimatic level stage, and then moving forward at the building level stage, with shading being the important strategies going at the first stage of the design. Then looking at the users as the main aspect of the Olympic village. The athletes are the user which are going to occupy the space for temporary period of 2 months. So I looked upon what kind of thermal environment is required for an athlete, and a wet bulb globe temperature is the scale identified to identify for the adaptive comfort strategy for an athlete, which has been given by the International Olympic Committee. It shows that during hot and dry periods, the performance of athletes decreases because of the high risk in thermal injuries. And I tried to plot the wet bulb globe temperature onto the Ahmedabad climate to look upon what should be the ideal period for Olympics to take place in order to reduce the thermal risk for an athlete. And it was identified that the original time period, which is July to August, is not a good period for Olympics to take place in Ahmedabad, and it should be shifted to October-November period. And in terms of indoor comfort, instead of using IMAC comfort band, which is a peculiar comfort band for climatic conditions in India, ASHRAE comfort band should be used, which is more global comfort band, and people can adapt to it more easily. And now moving forward into the permanent user, and just to identify what kind of day-to-day activities athlete versus a common user can do, and what kind of spaces do they use. So I started to look upon the morphology of existing urban form in Ahmedabad, and tried to learn from what kind of open spaces are created in Ahmedabad to guide the further steps for urban design. And the main morphology of the urban form was existence of courtyard. So I did a brief study of courtyard, what kind of height to width ratio, aspect ratio is ideal for climatic condition Ahmedabad, as a courtyard is a typology which is required even during the Olympic villages. And yeah, so the outcome of the studies showed that a three-sided courtyard with a height to width ratio of 2:1 can be an ideal one, wherein a selective ventilation strategy between the two courtyards can be identified in order to regulate the wind flow. So moving on to the site, which is the proposed site for the Ahmedabad 2036 Olympics. So these were the briefly 6 steps identified to go ahead with the urban form on the site, wherein steps like adding green spine, and then moving forward from having larger open spaces to smaller open spaces and connecting them in order to reduce the go from higher solar exposure to lower solar exposure, and then go into the building level, which can form smaller communities, which is useful during Olympics and even post for the communities. And these were the steps identified while designing the urban form. Then moving on to the building level, a transition space was identified going from outdoor space into the indoor space, which acts as where the courtyard and thermal buffer acts as a transition in order to have buffer between, like when you are entering directly from public to the private space, and a use of perforated panels as an element in order to restrict the wind flow between the buildings, and also to identify what can be done in terms of strategy for summer and monsoon. The panels were used, and this is the performance of the courtyard during a moderate day, wherein when the panels are opened up for additional ventilation, it shows that courtyard performs better, and the thermal buffer can further reduce the temperature, and people can use the thermal buffer space during that time. And this is the overall UTCI study of the courtyard, how it performs in the 3 different periods identified in the climate. A view of the thermal buffer space. Then moving on to the thermal study for a bedroom space. A typical window of 30% glazing was further designed to have panels and glazing reduced to 10%, which gives adequate daylight in order to reduce the temperature. And introduction of night purge with shade and insulation further gave reduced temperature, and then use of ceiling fan as a mode in order to further get the temperature within the comfort band even during the hotter days was achieved. For the apartments which are on the top floor, which are directly exposed to the direct radiation, strategies of filler slab and a double roof with green mat shade was used. And yeah, this is just a view of the whole, all the strategy on a moderate day when the panels are opened up to have more air, and during a hot day when the panels are closed, in order to block the air and have more comfortable temperatures in the courtyard. And a view from the entrance of the courtyard. Thank you.
Good afternoon, everybody. My name is Katarzyna Baczynska. This is my dissertation project, Retrofiting for Climate Change, Adapting Historic Industrial Building for Residential Purposes. So I'm focusing in Berlin as a city that was very well known for being really the epicenter of technological movement and progress in the beginning of the 20th century. It was known as a European electropolis, and what remains from that period is many, many industrial buildings that are still existing in the city. According to one database, there's still more than 200 buildings like that, and there isn't always really a clear idea of what to do with them, because the German regulation strongly limits any kind of interventions into their fabrics, so often they just remain abandoned. On the other hand, the current market state shows that there is a demand of approximately 700,000 units, dwelling units in Germany right now. And while the house ownership in Germany as a country is around 46%, in capital Berlin it's only around 15%. There is a huge issue with finding units, finding housing, and something more should be done about this, and more residential projects should be connected in the city. The country is also really tending towards smaller households, usually 1-2 people. This is the most typical size for the units. Multi-children families are not really a typical thing anymore. When I was looking at issues regarding this building, I really divided them into opportunities and issues, and also into the existing structure and a possibility of adding new constructions. So the opportunities granted by the existing mass masonry buildings is that they have a high thermal mass, they usually have high volumes which perform really well in summer, And it's really great saving on carbon emissions if we can renovate instead of construct something new. On the other hand, we often don't have an impact on their orientation, on their depth, and their fabric was insulated. These were buildings that were not initially planned for human occupation long term. So I was really trying to look at how to balance the opportunities in each project. And I arrived at my research questions, which were how to adapt the original floor to height ceiling, which is usually very large, up to 6 meters, what major interventions are worth pursuing if we were to go against the law that really limits any kind of intervention, and how to adapt those buildings to be as energy efficient as possible in a cold climate. The German climate is strongly heating or dominated, but it also has 4 distinct seasons, and summer can get very warm. This is the temperature chart for the year. And I chose 2 typical days, a typical winter week and typical summer week, but also really wanted to see how the building would perform during an extreme conditions during a very cold week, as well as a heating wave, which is particularly dangerous for buildings that have very high thermal mass. This is the map of Berlin. The city center is marked, as well as the weather station that was used for deriving all the weather files, and the site itself. And this is the proximity of the building. Most of the street is commercial. There's also a lot of residential buildings, but any kind of amenities that are necessary for humans are really accessible in a 1-minute walk. The dashed line is showing the city rail line, which is going directly behind the building. The building, this is the site. The building is currently owned by the city rail and is still operational. And I suggested to leave the ground floor as a kind of open rental space in keeping the spirit of the street, which is mixed use, and putting the trash enclosure and back storage in an ancillary building, while providing an acoustic screen with greenery as a protection from the noise pollution from the rail. This is the building itself. It's a rectifier plant and still serves as such. It was constructed in 1926 by an architect, Richard Braderman, who is the main architect of the Berlin City Rail. This is the historic section, which shows the really large volumes inside, and also historic plans that display. This is a 2-story building, and I will be focusing on a 1st story and an addition. I had an opportunity to go inside. These are the photos of the large volume that I'll be dealing with in this project. But as part of my fieldwork in Berlin, I also wanted to learn about what constitutes a good apartment. I had an opportunity to study a townhouse constructed also in the beginning of the 20th century. And over a hot summer week in summer, I installed 2 data loggers, one in the bedroom and one in the living room. These are the 2 charts showing occupancy patterns of the rooms. And I discovered that despite outdoor temperatures being very, very high, the temperature inside remained really comfortable. The building was also constructed of solid masonry and has ceilings of floor-to ceiling height of approximately 3.3 meters. My takeaways were that the high ceilings and no direct solar gains really contribute to keeping the temperature inside comfortable during a heat wave. And I also noticed that the balcony in apartment served as a really nice transitional space during that time. I really wanted to focus on balconies and transitional spaces in Berlin because they are beloved. So during the fieldwork, I also took a walk around the city to really photograph and see how people are using their balconies. And regardless of the building orientation, they are very, very popular and used throughout the year. I arrived at my design agenda, which was preserving the front elevation, which has really nice architectural value and is characterized by those ventilation shafts, preserving the existing staircases. But then the additional balconies was really only possible on a back elevation. So that was also one of the key things. And wanted to focus on introduction of the dual aspect units. And set up my comfort criteria. In terms of daylighting, pretty lenient, around 100 to 150 lux, and temperature relies on the adaptive comfort band. From my analytical studies, I wanted to look at how different units are performing depending on their orientation, and I discovered that a double aspect unit is always performing better in terms of heating load than single aspect units of a similar size. Follow this up by studying a unit on an intermediate level as compared to top level to discover that addition of top floors could be beneficial for the thermal performance of the building. Second part of my analytical studies focused on how to deal with the height of the floor, which is for 5.8 meters, and I studied 4 different possible volumetric layouts for a unit, ones that either employ the full height, only half height, or mixed solutions, and I arrived at the solution that the layout DD with mixed heights of rooms could be a good idea to pursue. This is how I decided to go about adding to the volume of the building, adding of the staircases, and adding of a top floor. And in terms of dealing with the section, we'll be both having stacked apartments of lower heights and having 2-level apartments. This is the program of the building. It has 17 units, out of which 4 are 2-bedroom plus office apartments that are double height. There are also studios and 1-bedroom apartments, so they cater to different occupant groups. The suggested floor plan, and because once again, only the opening of the back elevation was possible to add balconies, I decided to place living rooms from northeast side, which is not typically done, but I thought that the benefits outweighed the risks. This is the second level with the workspace as a loft space, and a top level that has terraces, and this time the living rooms are oriented towards the southwest. Section showing the double-heighted apartment and also the addition of a top floor. The opening of the back elevation constitutes a challenge because it is a northeastern elevation. From a thermal analysis point of view, it's not really desired. On the other hand, the compactness of the plan and the thermal performance I thought was good enough in order to justify such a move. And the benefits were significantly better daylighting and the inclusion of balconies, which will serve as a great space in summer when they will also be shaded from direct sunlight. This is the final daylighting autonomy for the proposed plans, where most of the rooms reach the threshold at least 80% of the time. And this illustrates the top floor, where entire area of units reaches the threshold over 90% of the time. In terms of thermal analysis, I really focused on 2 extreme cases, the smallest and the biggest unit. And in the existing part, I started with values recommended by current German building regulations, which are 0.28 U value for the external wall and 0.21 U value for the roof. And I studied how different rooms performed during winter and during summer. While the studio remained inside of the comfort band for most of the time, the living room and the bedroom obviously had much higher heating demands. While the bedroom located to the southwest was responsive to the solar gains and also had higher internal temperatures, the large living room performed pretty flat and was much more stable in terms of temperature. In summer, there was some overheating during the heat wave, so that was also something I wanted to mitigate, especially in compact studios directed to the southwest. I focused on both winter and summer strategies for improving the performance. For the winter, it will be improved fabric, including night shutters, and also adjusting heat, including variable heating schedule. And for the summer, low-E coated windows, improved ventilation, and also using the existing ventilation shafts for stack ventilation. These are just results for the biggest apartment for the winter, and we can see that addition of night shutters and improved fabric can raise the internal temperatures by 3 degrees during even the very cold winter week. While in summer, inclusion of additional ventilation, especially the use of the vent shafts, really allowed to lower the temperature to comfortable levels even during a prolonged heat wave. For the new, I conducted the same round of simulations for the new construction. Here are the results with all the improvements. And during summer, I also decided to include external blinds as a shading device, and they were tremendously helpful in lowering internal temperatures during a heat wave week. The tables show the summary of simulated heating and cooling loads on base case scenario, which is the German regulation fabric properties, improved fabric qualities, and also predictions for the year 2100. And I was very happy to see that in almost half of the cases, I was able to receive heating cooling close of 0. The diagrams show adaptive behaviors and also passive building performance during different days of the year. During a typical winter day in a double-height apartment, we keep the windows open during the day to allow for some heat gains from the southwestern side, while at night, insulated shutters allow to keep the heat inside. While during a very hot summer day, low E windows limit the amount of sunlight getting inside, while the thermal mass helps to stabilize temperatures. And then at night, we use the open windows and also the ventilation shafts for nighttime cooling. These are also outside views of the buildings, showing how the terraces are being used. And thank you.
I can start. Yeah, I can make a couple of comments. Thank you for such a thorough piece of work in both cases for your presentation. I would like to add something. In both cases, because I think your project has a number of qualities that maybe in the short time you didn't speak out so clearly, and I would really like to underline. Starting from the Ahmedabad one is, I mean, the challenge of that summer, and especially in the future of climate change, is maybe one of the most difficult ones that we have faced. We are talking about a climate that get, what, 40, 50 degrees? 44, yeah. Well, the future of climate change, I've just came from Ahmedabad, they are predicting something close to 50. And you went very quickly through the strategies, Stavan, but maybe what will save those buildings and people inside those buildings is the combination of mass, fabric, and compact form, but with a series of transitions, again, that have a role in every single climate. So I think it's very clever the way you articulated the compactness, the fabric, and added the element of, I would use the word adaptability for the ventilation, the controlled ventilation, as the climate changes through the year. And this adds incredible quality to the spaces and involves the users as well. So I would like to highlight that because I think this is maybe the success of your proposal lies in this combination. A building that can be a cave when it's 50 degrees outside and can be almost like a tree, completely open when ventilation is wanted, when we want to couple. So you did this very well with the right proportions and the specifications, and I wanted to call the attention for that. And I think in a way, I see the same work in Kasha's project, because you're working with an existing fabric, you're coupling with this fabric. So maybe we saying that we want heavy buildings towards the future of climate change, heat waves. So we need to bring mass back, whether it's in the hot desert of Ahmedabad or the continental climate of Berlin. And how much is this going to change the face of buildings that at the moment are very lightweighted and insulated? So you are putting a new perspective by working with this one element called the heavy fabric, which I think it opens opportunities for architecture that we need to start exploring again. Yeah, thank you.
Thank you, Joanna. Well, I think it's quite difficult to compare both, so I'm not going to compare. Both of you deal with the residential buildings, and both deal with a changing client, let's say, or occupants. In case of Stavan is about first having these athletes with very specific requirements and need for outdoor spaces for the training and sharing spaces differently from what it will be in the future, which will be a more permanent solution for a long-term occupancy. Of course, as Joanna said, the challenge was very much the climate. And in Kasia's situation, well, I think it's you know, it's very common to have these existing structures and looking into rehabilitating those, but in your case, changing completely the type of building, so from a industrial structure for inhabitation, was a very interesting proposal. I think both of you dealt with very practical issues, almost like a real situation, although you didn't stop to explore things like in case of Kasia, she did go beyond what regulations would ask you to do. So you managed to bring that maybe regulations also need to be changing because there are opportunities which can be missed. And I think with Stavan it was very interesting to see how he brought the traditional courtyard and the massing and urban design to enhance the quality of a very much needed area to be developed. And well, I congratulate both for your presentations, and I'm going to pass to my colleague, George.
Thank you. I think that despite the fact that there are almost radically different projects, there are things that could be that transpire from both of them, and one is this a methodology in which there are, I could see mainly these two stages, one in which you very carefully define the criteria, a framework for the design, and this makes also the project very transparent and clear in order then when we look at it and we evaluate the project, we see whether these initial criteria are met, and these criteria include the climate, include the uses, but also includes the architectural values of existing buildings. For instance, when you state that one of the intentions is to preserve these elevations and also to preserve the scale of the building, not to grow much higher than the existing building or the buildings around it. So I think this clear definition of an initial framework is very useful. And then in the second stage, the develop evolves, is developed, and despite that in the presentations it is a very linear process, and it seems like all your numbers and everything flows linearly. It is in fact is very iterative. When you say, for instance, in the case of the Olympic Village, you test the window to flare ratio of 30%. It seems that it's a number that has been already always there, but we know that it's been an iterative process, and that was more evident with the retrofitting case, where you showed us the different division possibilities and the consequence of them, so you can weigh them, you can compare, and then see which one of those presented the better opportunities and advantages. And I think in both cases there is this two-stage process and methodology that in the end inform the building design and allowed you to come up with these solid projects. Thank you.
I was quite impressed with the speed of your presentations. Found it a bit hard to follow, but it did show how well you have mastered your topics, which is commendable. I think, however, that for me the speed of the presentation made it difficult to retain the key aspects. I mean, what are the key factors? With the Olympic transformation, we have the courtyard that you presented as a key, and a lot of studies around the courtyard, but not that clear a definition of the criteria that will decide the outcome of these studies. I think that could be something to go back to, because we have many times seen in the research literature as well as in building studies the courtyard being made the savior of the building, the environmental center, the solution to all issues. And then in reality finding that it's not necessarily that way, and being able then to redefine what were the pros and cons. I found some input data in Kasia's project, not clear. I think that there are input data which define shutters that are either wrong or perhaps the unit is wrongly shown, and it would be good, together with the internal gains, which are pretty high, something like 20 watts per square meter, I think. 15 plus 5, somewhere. But what is very interesting, I think, is that there is a good solution for the building with a good performance resulting that cannot be faulted, irrespective of whether the input data that I mentioned are right or less right. I think that the simulations show the kind of behavior that this building has with the stuff with which it was built and with the proportions that its spaces have. So that the characteristics of the building have been identified, and I think you've respected them. And although there are interventions in there which improve the environmental performance and quality, they do not detract from the building's original character. And I think it would be good to, together with the climate change, which is taken into account there, and we see things, how the building might be performing in the future. And for some people, there will be also the surprise that in the winter it will perform better in a few years than it does now, which is quite interesting. So anyway, well done, both of you, and thank you for good presentations.
Thank you.